I hope you are having a great day today. Just to recap a question from Friday. This is example number 10. So remember when you're solving polynomial equations, one of the methods we said we could use is factoring. And remember, if we have an even exponent in our first term, our second term has an exponent that is exactly half of that first term's exponent, and our last term is a constant, we can factor this exactly like a quadratic. So in order to find our roots, we also know that that's when y equals 0. So we can say 0 equals this. So to factor this, I'm going to multiply 4 times 4 and find factors of 16 that also add to that middle term, 17. And of course, those numbers are 16 and 1. So we can turn this into a grouping problem. So we keep the first term the same. We replace the middle term with the two numbers that we found over there on the right. And then we need to keep the middle variable with it. So we'll have x squared with our 16 and our 1. And then the last term stays the same. And then to do grouping, we do a greatest common factor 3 times. So if I just look at the first two terms, my greatest common factor of those two terms is 4x squared. And when I divide it out, you end up with x squared plus 4. And then the middle symbol is a plus sign, so we'll put a plus sign next. And then the last two terms has no GCF other than 1, so we'll just factor out a 1. And when you divide by 1, you still have x squared plus 4. Then from there, you can see we have two large terms that have x squared plus 4 in common. So you can divide out that x squared plus 4 as the greatest common factor. So when you divide it out, you're just left with the stuff in front of the parentheses. So it's 4x squared plus 1. Now remember, once you finish factoring, we need to separate our factors and set each factor equal to 0 and solve those equations independently. So in the first one, subtract 4 from both sides. So x squared equals -4, and then square root both sides. Now remember, when you square root both sides, you have to have a plus or minus on your answer. And then when you square root a negative number, you also have to remember that you will have an I in your answer. So the square root of 4 is 2, and we get I. So this is two of our answers. We have a positive 2i and a negative 2i. And then on the other one, of course, you'll subtract the 1 first. So you get 4x squared equals -1. Then divide both sides by 4. So x squared equals -1/4. Then from there, to get rid of the squared, you're going to square root both sides. And then you get plus or minus because you square rooted both sides. And then the square root of 1/4 is 1/2. And then, of course, because you're squaring a negative, you have an I. So you have positive 1/2 I and you have negative 1/2 I. So those are the 4 solutions to this equation. So today what we're doing is we are doing this backwards, okay? So instead of solving the equation, we're going to write the equation given solutions. So one thing to notice is that if you look here at this step where I set x squared plus 4 equal to 0, the first thing I do is I do the opposite of the plus 4 and subtract 4 to move it over. So remember, if your solution, let's just pretend it's at x equals 4 or x equals -4. To go backwards, you would have that opposite sign there. So in this next question, where it says we're writing an equation and we're given the solutions, you just have to remember when you put the solution back into the parentheses, working backwards, we're going to have the opposite operation. Because if x equals -4, to get this back equal to 0, we'd have to do the opposite to add that 4 back over. So x plus 4 is the actual factor here. Okay, so what we're going to do to write our equation is we're going to just remember that it's the opposite. So we're going to have x plus 4, and then when positive 7 is an answer, that factor factor starts as x minus 7, because if you set x minus 7 equal to 0 and solve for x, you would add the 7 to both sides, so that's why you get a positive 7 as an answer. So from here, technically we're done. We've written a polynomial equation of least degree with the following solutions. So sometimes you'll need to multiply it out. It depends on if it's a multiple choice question where you have your answers in standard form. Sometimes they'll be in the same format here and you don't have to go any further. But if you do have to multiply it out, just do that distributive property. So x times x is x squared. And then you'll do the x times the negative 7. And then distribute the 4. 4 times x is 4x. And 4 times negative 7 is negative 28. And then combine your like terms for your final answer. So you have x squared, and then you can combine the negative 7 plus 4, so that's minus 3x, and then minus 28. So that would be your solution there if you needed to multiply it out. So on letter B, you would do the exact same thing. You would set it up by doing the opposite for each of your factors. So the positive 3 solution would be x minus 3 in the parentheses. The positive 4 solution would give you an x minus 4 in the parentheses. And then the minus 2 would give you an x plus 2 in the parentheses. So you would need to just take 2 of those and multiply them together first, and then you can multiply by the third one. So it really doesn't matter which 2 you multiply first, since multiplication is commutative. So on the first 2 there, I'm just going to multiply the first 2 together, x squared, and then you get a minus 4x and a minus 3x, so that'd be minus 7x. And then negative 3 times negative 4 is a positive 12. And then, of course, we still have x plus 2 there at the end. So from here, we can, I'm going to do it the other way. I'm going to take the x and distribute it back this way first. So that's x cubed minus 7x squared plus 12x. Oops, that's a plus sign there. And then distribute the 2 to all 3 of these. So we get plus 2x squared, and I'm running out of space, minus 14x, and then plus 24. And then, of course, you would just combine your like terms for your final answer. So we have an x cubed. It looks like there's a minus 7x squared and a plus 2x squared, so that's minus 5x squared. Then we have a 12x minus 14x, so that would be negative 2x, and then a plus 24 at the end. So that would be the solution. Alright, so now, what if the question gives us imaginary solutions, and we have to go backwards like this to write the equation? Then what do I do? You're essentially going to do the exact same thing. The only thing that you have to remember about imaginary solutions is that if we go back to this previous example, if you notice, both of the imaginary solutions that we have, they have a plus and a minus, because those imaginary solutions are created by square rooting both sides, which results in that plus or minus. So all imaginary roots or solutions, they come in pairs. So there's always a plus and a minus. So if a plus bi is a root or a solution, then a minus bi is also a root or a solution. And we do call these conjugate pairs, or we just say conjugates. So on example 16, where it says find the conjugate of each of the complex numbers, you're essentially just changing the sign in front of the imaginary part. So positive 4i's conjugate is negative 4i. The conjugate for negative I is positive I. The conjugate for 2 minus 3i would be 2 plus 3i. And then the conjugate for negative 4 plus 2i will be negative 4 minus 2i. So you just want to make sure that the sign in front of the imaginary part just gets switched. So on example 17, where we're writing the equation just like we did on example 15, they only have one of those imaginary numbers listed, so it's up to us to remember, oh, there's actually a second one there. So if 2 plus I is a solution, we need to remember that 2 minus I is also a solution here. So if you notice, we have a real solution of the number 1, and then we have that pair of imaginary solutions. We have 2 plus I, and we have 2 minus I. So when we put our solutions into the parentheses, just like on example 15, you have to remember to do the opposite. So it's always x minus or x opposite your root. So if I'm going to write a function equation for this one, with a positive 1 there, you're going to have x minus 1. And then I'm going to subtract or do the opposite of both terms of the imaginary solution when I put it in the parentheses. So we're going to start with x, and then we're going to minus the first root. So if we're going to subtract 2 plus I, we have to distribute that minus. So minus 2 minus I. And then for the third root, 2 minus I, if we put that in the parentheses, we have to do x, and then we have to subtract both terms. So we minus 2, and if we're minusing a negative I, that's going to be plus I, like that. So we end up with this here. So when we're multiplying this out together, you always want to multiply these conjugate pair parentheses together first. And if we do it all correctly, all the i's should cancel out and go away. So I'm going to leave that x minus 1 there in the front first. And I'm going to multiply these other two trinomials together first. So I'm going to distribute the x first. So x times x is x squared. Then the x times the negative 2 is minus 2x. X times I is just I times x. Then I'm going to distribute the negative 2. Negative 2 times x is negative 2x. Then we have negative 2 times negative 2, which is a positive 4. And then negative 2 times I would be negative 2i. Now I have to take this negative I and distribute it. So negative I times x is negative ix. Then negative I times negative 2 would be a positive 2i. And negative I times positive I would be negative I squared. So if I go to combine all my terms, let me write down this part that's still there. We haven't done anything with that yet, so that x minus 1 stays there. So if I combine all my like terms, we have x squared, and then we have a negative 2x and a negative 2x, so that makes a minus 4x. And then the ix and the negative ix, these two add to 0, so I plus negative I would be 0. And then if you notice the other terms that have i's, the negative 2i plus 2i, negative 2 plus 2 is also 0. And then we need to remember something about I squared here. I squared is actually negative 1, so this is subtracting a negative 1. So it's really a plus 1. So when I go to combine 4 plus 1, that's going to be a 5 right there. And then we just need to distribute the x minus 1 times that quadratic trinomial there. So let me multiply it all out. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 5 is 5x. And now we need to distribute the negative 1. So that would be a negative x squared. And then a positive 4x, and then a negative 5. And one last final step, combine your like terms. So x cubed, and then let's see here, negative 4x squared and a negative x would be negative 5x squared. Then we have 5x plus 4x, we have 9x, and then a minus 5 at the end. So that would be your polynomial. All right, example number 18 expands on something that we've already talked about. So we already said that if we have consecutive equal length input value intervals, Okay, so we already said if we're increasing by the same amount in the x's here, then we can just find the differences in the y's in order to determine if we have a linear or a quadratic function represented in the table. So if we find the difference here, we have 3.6 minus 2, so that difference is 1.6. Then if I find the difference between 14.8 minus 3.6, that gives us 11.2. So already we can see this one is not linear because those differences there have to be the same in order for our function to be linear. So let's keep going and see if we can figure out what degree our polynomial equation is. So 45.2 minus 14.8 is 30.4. Come on, Ben. There we go. And then 104.4 minus 45.2 is 59.2. And then 202 minus 104.4 is 97.6. All right, so like we said, this one is definitely not linear. So let's find our second differences to see if it's quadratic or not. So 11.2 minus 1.6 is 9.6. And then we need to find the difference between 30.4 minus 11.2, and that's 19.2. So already you can tell this is not quadratic either. I'm going to keep going though. 59.2 minus 30.4, that's 28.8. And then the last one, 97.6 minus 59.2, and that's 38.4 here. So if the first differences were the same, then your function would be linear. If those second differences are the same, your function would be quadratic. So if we have third differences the same, check this out. We have 19.2 minus 9.6, so we get 9.6 there. And then 28.8 minus 19.2, look at that, 9.6. And the last one, 38.4 minus 28.8, and that's also 9.6. So these are the third differences. So if the third differences are the same, then the original function will be a cubic polynomial or a degree 3 polynomial. So this function is cubic, or it could be cubic, because those third differences are constant. So if you look up at the top up here where it says successive differences over those equaling input value intervals, it says the degree of the polynomial equals the least number for which there are constant differences. So basically what that's saying is first differences, if those are constant, then the degree of your polynomial is 1, which is a linear function. If the second differences are constant, then your degree of your polynomial will be 2, or a quadratic function. If the third differences are constant, the degree of your polynomial is 3. It will be a cubic function. So it keeps going from there. If those third differences are not constant either, do the fourth differences. If the fourth differences are constant, you guessed it, it's a quadratic function that has an equation with a degree or exponent of 4. If those aren't the same and the fifth differences are constant, then it would be a 5th degree polynomial or a quintic polynomial. And it just keeps going from there.